First off, first topic, osmosis and diffusion. Both are ways that molecules move around in the body. This is important because a lot of the action in physiology is about things moving around, either moving across the membrane or moving from one compartment to another. So we're going to talk a lot about things powered by diffusion and osmosis. All right, so diffusion is free motion. Okay, you all learned in your physics class, and probably in general chemistry too, that temperature creates motion, right? So that's Brownian motion. Molecules are always wiggling around. That's true in our bodies as much as it's true in the heart of a star, okay? So because molecules are moving around all the time, there's a tendency for things to move from areas of high concentration to areas of low concentration. We call this diffusion, movement down a concentration gradient, okay? Now, the important and I think critical bit about diffusion is it's free, right? We don't have to put any energy in to move things by diffusion. It's one of the reasons that the body prefers this methodology. It doesn't require any ATP, right? So it's very efficient. Osmosis is a special form of diffusion. We tend to think and talk most about water-based systems, okay? So we have molecules dissolved in water. We have solutes in a solvent, right? So we talk about diffusion in terms of the solutes, what's moving in the solution. Well, osmosis is water's diffusion, which, as far as I'm concerned, that is very confusing, right? And I'm sure you have had chemistry teachers who have done a great job explaining it to you. I can never quite get it. So I just remember the rules, that osmosis is the movement of water from areas of low solute concentration to areas of high solute concentration. Essentially what it's doing is it's moving from areas of high water concentration to areas of lower water concentration. But that, at least for most of us, just doesn't quite fit in the noggin. All right, so some pictures. In order to have diffusion, you have to have a difference. In other words, you got to have more molecules on one side of a thing than you do on the other. So in my picture here, you've got high concentration on this side, very low concentration on this side. As the molecules wiggle around Brownian motion, over time, that concentration gradient disappears, right? So we have diffusion. Some of the molecules on the left moved towards the right. Now, in our body's systems, a lot of times the concentration gradient is maintained. Okay, so what is a concentration gradient? It's a difference between a high end and a low end, right? So one side of the box is high, the other side of the box is low, so therefore we have a gradient, a concentration gradient from one side to the other. Osmosis in a picture. We have water and we have solute. Okay, in this case it's sugar. The solute molecules are purple and the water molecules are blue. Down through the middle of this system, we have what's called a semi-permeable membrane. This is a fake cell membrane, essentially. We're going to talk a lot about membrane tomorrow, but one of the characteristics of a membrane is that it lets some things pass, but not other things pass, right? So if you have a membrane like that allows some things like water to pass, but not other things like sugar to pass, you have a setup for osmosis, where water is going to move from areas of low concentration of solute to areas of high concentration of solute, right? So we get a net movement of water, in this case from the right side to the left side. Now, as more water moves this way, the pressure of this column is getting higher and higher, right? So at some point, the planet pulling on this water is going to stop more water from moving in. All right, that's what we call the osmotic pressure. And we'll talk more about that when we get into the kidney system.